and welcome back to Statistics and Probability class. In this video lesson, you are expected to indicate the type of random sampling illustrated by the given situations and to create a sampling distribution. To start with, let us define three important terms. A population includes all of its elements from a set of data. The size of the population is the number of observations in the population. A sample, on the other hand, consists of one or more data drawn from a population. Random sampling, meanwhile, is a sampling method of choosing representatives from the population wherein every sample has an equal chance of being selected. This random sampling has types. First, simple random sampling is the most basic random sampling wherein each element in the population has an equal probability of being selected. An example is when a researcher writes the name of each student on a piece of paper, mixes the papers in a box, and draws 10 pieces of paper. Systematic random sampling selects every kth element, K, of the population until the desired number of elements in the sample is obtained. In getting the kth interval, divide the population size, N, by the sample size, N. Okay, again, population size is represented by capital letter N, while sample size is represented by small letter n. An example of systematic random sampling is when a population consists of 1,000 students and there are 50 desired samples. A researcher then tells the students to count and then selects every 20th students. Stratified random sampling involves dividing a population into different strata or divisions. The number of samples are proportionately picked in each stratum, thus all strata are represented in the samples. An example is when a researcher separates the lists of academic, sports, arts and design, and TBL tracks. A researcher then draws 7 names per strand or per track. Cluster sampling. It involves dividing a population into clusters or groups, and then the clusters are randomly selected. All elements of the clusters randomly selected are considered the samples of the study. An example is when a researcher surveys all students from 4 randomly selected classes out of 7 classes. Researchers use sampling if taking a survey for the entire population is impractical. A parameter is a measure used to describe population. This includes population mean, mu, population variance, sigma squared, and population standard deviation, sigma. On the other hand, a statistic is a measure used to describe sample. This includes sample mean, x, sample variance, s squared, and sample standard deviation, s. A sample mean, for instance, is an estimate of the population mean. Sampling distribution of the sample means is a frequency distribution using the computed sample mean from all the possible random samples of a particular sample size taken from the given population. The means vary from sample to sample. That is, the sample mean is a random variable that depends on a particular sample. And being a random variable, it has a probability distribution, which is called as sampling distribution of the sample means. These are the steps in making sampling distribution of the sample means. So first, determine the number of sets of all possible random samples that can be drawn from the given population. Use the formula combination of n things taken n at a time, where n is the population size, n is the sample size, and combination of n things taken n at a time is the combination of n taken n at a time and can be manually solved using the formula or use your calculator function. NCR, or combination of n things taken r at a time. Second, list all the possible random samples and solve for the sample mean of each set of samples. Third, construct a frequency and probability distribution table of the sample means indicating its number of occurrence or the frequency and probability. You'll understand this better in the example.
Example, a population consists of values 1, 2, 3, and 4. Create a sampling distribution of size 2. The given in the problem is the population, denoted by capital N, which is 4, and the sample size, denoted by small n, which is 2. So we will follow the steps we've enumerated earlier. Step 1, we are going to solve for the total number of possible sets of the random samples. So we will use the formula for combination of n things, capital N things, taken n at a time, that's small n. So this is that formula. Combination of n things taken n at a time. So that is equal to n factorial, population factorial, over sample size factorial, times the factorial of population minus sample. By substitution, this is what we will get. The combination of 4 things taken 2 at a time is equal to 4 factorial over 2 factorial times 4 minus 2 factorial. We know that 4 factorial means 4 times 3 times 2 times 1. Or it can be written as 4 times 3 times 2 factorial, because 2 factorial also means 2 times 1. But why did we write here 2 factorial? Why? We may write 2 factorial because we may just divide it by the same factor in the denominator. But we may opt, of course, to write here 2 times 1, and then the denominator may be written also as 2 times 1. But we'll arrive at the same thing. We'll be dividing a number by itself, and that is equal to 1. Just to show you that they are equal, we will be dividing a number by itself. Then I opt to write it as 2 factorial. So for you will see that the essence of that when we are dealing with big numbers. Let's say, for example, we have here 7 factorial over 4 factorial, then you may opt to write 7 factorial as 7 times 6 times 5 times 4 factorial. Then 4 factorial divided by 4 factorial is 1. Okay, going back, because that might be a question to a student, that's why we detail that part, we explain that part. So, 2 factorial divided by 2 factorial, this 2 factorial comes from 4 minus 2 factorial. 2 factorial divided by 2 factorial is 1. So, this is the same as equals 4 times 3 over this 2 factorial is 2 times 1. And then, we still have a common or uncommon factors here. 4 is 2 times 2. So, this can be reduced to 2 times 3. Why did it become 2 times 3? Because 4 divided by 2 is 2. So, you'll have here 2 times 3. And here, this becomes 1. 1 times 1 is 1. So, 2 times 3 over 1 is the same as 2 times 3. That means, the combination of 4 things taken 2 at a time is 6. Then, let's proceed to step 2. In step 2, we are going to list down all the possible combinations of samples, and then get the mean of each. So, the first sample, because the sample size is 2, and given these numbers in the population, so the possible combinations of the samples may be 1, 2, 1, 3, 1, 4, and then 2, 3, 2, 4, and 3, 4. So there are 6. Then let us find the mean of each pair. Again, to get the mean, recall that you will just get their sum and then divide it by the sample size. In this case, the sample size is 2 all throughout. Then that will be 1 plus 2 divided by 2. That is 1.5. 1 plus 3, 4 divided by 2 is 2. And so on. So this is the corresponding mean of each sample or combination of samples. We are now down to the third and last step, wherein we are asked to construct a frequency and probability distribution table. So first, in the first column, write all the possible sample means from step 2. And then, wherein in step 2, again, just to recall, we find the sample means of the corresponding of each possible combination of samples. So, the frequency that the sample mean is 1.5 is 1. There is only one combination of samples where the sample mean is 1.5. So the frequency is 1. As well as with 2, the frequency is only 1. Now from step 2, we have seen that there are two combinations of samples where the sample mean is 2.5. So the frequency is 2. Then again, for sample mean 3, the frequency is 1, as well as with 3.5 sample mean, the frequency is 1. And then after finding the frequencies, the third column for step 3 is the probability. First, get the sum total of this. This is 6. So the probability that the sample mean is 1.5 is 1 over 6. The probability for this row is also 1 over 6. For 2, that's 2 over 6 of course, and in lowest terms that is 1/3. And then for 1/6 also, or for 3, for the sample mean 3, that's 1/6, the probability is 1/6. And for sample mean of 3.5, the probability is also 1/6.
It is important that the chosen sample is a good representative of the population, so sampling should be done carefully. Until next time!